that little mouse, cause I'm an albatross. I'm an albatross.
Ho 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 ho! Merry Christmas everyone and welcome back to our channel.
Welcome to SUMATHIM.
And for today's video, we are going to tackle the
Introduction to logarithmic function.
In the first semester, you were introduced to inverse function. Inverse function is the set of ordered pair obtained by interchanging the x and y values. Next, you will find the inverse of an exponential algebraically. Y is equals to a by the power of x. Interchange x and y. X is equal to a by the power of y. We rewrite this function as x is equals to a by the power of y into logarithm, which is y is equal to log x to the base a. So here's some example of exponential function converted into logarithmic functions. First, or a, we have 3 to the power of 3 is equal to 27. So when we convert that into a logarithmic function, it can be rewrite as log 27 to the base 3 is equals to 7. Next, we have the b, which is 4 to the power of 5 is equals to 256. When we convert that into a logarithmic function, it can be rewrite as log 256 to the base 4 is equal to 5. Next, we have the c, which is 2 to the power of 7 is equals to 128. So when we converted that into a logarithmic function, it can be rewrite as log 128 to the base 2 is equals to 7. So next, we have a 1 over 3 to the power of x is equal to 27. When we rewrite that into a logarithmic function, it can be write as log 27 to the base of 1/3 is equals to x. So here is an also example when we convert the logarithmic function into exponential function. So log 64 to the base 2 is equals to 6. So when we rewrite that into a exponential function, it can be written as 2 to the power of 6 is equals to 64. Next, we have log 5 to the base 25 is equals to 1/2 or 1 over 2. So if we rewrite that into an exponential function, it can be write as 25 to the power of 1 over 2 is equal to 5. So we have c, log 1 to the base 8 is equals to 0. Again, when we write that into a exponential function, it can be rewrite as a to the power of 0 is equal to 1. Next, we have log 1/3 log 9 to the base of 1/3 is equals to -2. When we rewrite that into an exponential function, it can be write as 1 over 3 to the power of -2 is equal to 9.
So, we should always take note of this. There are two special logarithm values that you should learn to recognize. Let b be a positive real number such that b is not equal to 1. You should always take note of this. There is a logarithm of 1, meaning log 1 with the base of b is equal to 0, because b to the exponent of 0 is equal to 1. And then the second one, logarithm of b with base b, meaning log b with the base b is equal to 1 because b1 or b to the exponent of 1 is equal to b. So in this section, we will discuss about type of logarithms that we should also take note. So the first one, logarithms to base 10 are called common logarithms. Logarithms to base 2 are called binary logarithms. And logarithms with the base e are called natural logarithms. So in this section, we have some answered examples of Before looking at the answer key, we should try it ourselves first. We should answer it ourselves first. You can use the answer as a guide if you are correct. You can pause to take some time for answering. Let's just rewind a bit. I think Ymman is forgetting something, huh? So, in all, we ask, what is a logarithm? A logarithm is the power or exponent to which one base number must be raised and then multiplied by itself in order to produce another number. For instance, in the base 10 system, 10 must be multiplied by 10 to produce 100. So the logarithm of 100 in a base 10 system is 2, since 10 times 10 is equal to 100, and there are 2 10s. So the answer is 2. So logarithmic functions have many real-world applications, including measuring pH, measuring earthquake intensity, measuring sound intensity, calculating compound interest, measuring exponential growth, and measuring radioactive decay. Please read the description for further analysis or description. Okay. So, we use in this situation the real-world applications of logarithms. So, the situation is a gardener uses the app to monitor soil pH for growing tomatoes. We act that this app is used by plantitos and plantitas to detect the rate of pH. So the pH sensor detects hydrogen ions is equal to 10 to the power of negative 6 per mole. And then in the first box in the right side, the pH of a solution is calculated using the logarithmic formula, which is the logarithmic formula is pH is equal to negative log hydrogen ions with the base 10. So we insert the given or input the given hydrogen ions into the formula. Then the result would be pH is equal to negative log open close and open parenthesis 10 to the power of negative 6 with the base 10. And then using the property of logarithms, log 10 close and open parenthesis 10 to the power of x is equal to x. We can simplify it. So the result would be pH is equal to negative close and open parenthesis negative 6. And then after we combine the negative to the close and open parenthesis negative 6, the result would be pH is equal to 6. Then our conclusion is the pH of the solution is 6, which is in the rate would be which is slightly acidic. We can show you a list. So overall, learning and teaching logarithmic functions is about more than numbers. It's about showing how math connects to the world by using feedback to make lessons clearer, more relatable, and hands-on. Abstract ideas became tools for solving real problems. This process proved that with the right approach or right process, even challenging topics like logarithms can inspire curiosity and confidence in learners like us. This has been John Hippolito Timtim and Ymman Suzon. Thank you for watching.